This video focuses on solving radical equations. There are 4 different cases I'm going to work through, but as I go through each problem, you're going to notice that the steps are very similar for each one. Starting with example 1 is equation with nth roots, meaning we're starting off with exponents. The first thing we want to do is isolate whatever term is being taken a power of. So here I have 2x to the 4th power equals 162. So I want to isolate the x to the 4th power. I'm currently multiplying it by 2, so I'd have to divide by 2. Then the second step we would like to undo. So to undo an exponent, we take a root. Just like how when we had x squared equals something, we would take the square root of each side. But also, the most common mistake that you guys made was whenever you take an even root of each side, you need to put plus or minus. In fact, let's write that down. So even roots need plus or minus. If it were an odd root, like a cube root or a fifth root, we would not put that plus or minus out front. And it deals with the number of solutions these things have, which we already discussed in previous notes. Okay. Of course, I'd like to simplify this further if I can. So the 4th root of 81 is actually just 3. So it would be plus or minus 3 because 3 to the 4th power is 81. Now we need to check for extraneous solutions. We're going to check both of our solutions, a positive 3 and a negative 3, and we do that just by plugging it right back in. So 2, 3 to the 4th, 162. And then we have 2 times negative 3 to the 4th power equals 162. Okay, this 4th power only belongs to the 3, so we have 2 times 3 to the 4th power, which is 81. 2 times 81 is 162. So we get the same thing on both sides of the equation, meaning that it works. Over here, we have 2 times negative 3 to the 4th power. So negative 3 to the 4th power is actually a positive 81. Because think about it, negative 3 times itself 4 times, so negative 3 times negative 3 times negative 3 times negative 3. Two negatives makes a positive, so we have a positive and positive, so that's positive 9 times positive 9. And 9 times 9 is 81. So that's how I got that. And we can see that 162 does equal 162, so both are solutions. Part B. First thing is to isolate the term that has the power. And this is already isolated. I cannot add the 2 to each side because this is a part of what's being taken to a power. So I'm not multiplying it by anything, I'm not dividing it, I'm not adding or subtracting anything on the outside, it's already isolated. Step 2 is to take the root and undo the power. To undo a cubed, I need to take the cube root. What we do to one side, we have to do to the other. Now, since this is an odd root, we do not need to put plus or minus. So we're left with x minus 2 equals the cube root of 10. Now, step 3, we need to take any extra steps necessary to isolate the variable. So we're basically just solving for x. To get x by itself, I add 2, leaving me with x equals the cube root of 10 plus 2. If I could simplify this radical any further, I would. However, the factors of 10 are 1 and 10, 2, and 5, and none of those are perfect cubes, so it's actually just going to stay like that. And then we need to check our solution. We have the cube root of 10 plus 2 minus 2 cubed equals 10. The The 2's cancel, so I'm left with the cube root of 10 cubed equals 10. A cube and cube root cancel each other out, so it's 10 equals 10. Example 2, now we're going to be solving something that has a radical. So in example 1, we started with a power, and to undo the power, we took a root. Now we're starting with a root, and to undo the root, we're going to take a power. So they're kind of just opposites. First step is still to isolate the root. So I'm looking here, I have a cube root of x, and then I'm subtracting 4 from that. So in order to isolate, I have to add 4 to each side. And then we're going to have to undo the root by taking the third power of each side. That would make it so x is just by itself, and then I have 4 cubed. Remember, that's 4 times 4 times 4, which would be 64. And we've already solved for x, so I don't have to do any extra steps. We're going to go ahead and check. Make sure this really is the solution. The cube root of 64 minus 4 equals 0. 64 is a perfect cube of 4. So minus 4. That really would give us 0, so it does work. Okay. B. We need to isolate the term that has the radical, so I need to isolate the cube root of 4x plus 3. It's currently being multiplied by 5, so I need to divide by 5. The cube root of 4x plus 3 equals 15 divided by 5 is 3. And then we need to undo the cubed root by taking the third power of each side. So that's 4x plus 3 equals 3 cubed is 3 times 3 times 3. 3 times 3 is 9 times 3 is 27. Now I need to take any extra steps to isolate the variable. So we're solving for x. I would subtract 3 from each side. Divide by 4. X equals 6. Let's make sure this isn't an extraneous solution, so we're just going to check it real quick by plugging it right back in. Okay, so I have 5 times the cube root of 4 times 6 is 24 plus 3, which means it's the cube root of 27. 27 is the perfect cube of 3. 5 times 3 really is 15, so it does work. Example 3 once again has a power, but this time it's a fractional exponent. So the process is still pretty similar. We need to isolate whatever is being taken the power. So to isolate the x to the 3/2 power, I need to divide each side by 2. Gives me 125 on this side. All right, now, okay, so now what I'm going to do is I want to, these next steps are just talking about basically undoing what we have here. So I want to get the x by itself. In order to undo it, I'm going to raise both sides to the reciprocal power. So 2/3 power, because 2/3 is the reciprocal of 3/2. And what happens here is now I have a power to a power, so 3/2 times 2/3 is 1. And then I have 125 to the 2/3 power. I'm going to rewrite it as power over root. Power would be 2. Root would be 3. So this is x equals the cube root of 125 being squared. The cube root of 125 is 5, and I'm squaring that. So x equals 25. Now we need to check our solution. So it's 2 times 25 to the 3/2 power equals 250. So I'm going to use power over root to help me check here. 2 to the power of 3 square root of 25. So that's 2 times the square root of 25 is 5 being cubed. 2 times 5 cubed, so that's 5 times 5 times 5. So that's 125. And 2 times 125 is 50. So yes, that does work. Okay. B. The thing that's being raised to a power is already by itself. Now there is an x over on this side, so that's going to come into play later, you'll see. But this right here is already isolated. To undo the 1/2 power, I'm going to square each side because the reciprocal of 1/2 is 2 over 1, or that's just 2. So now over here, I have 2x squared. Think of your properties of exponents. I have two separate things, so two separate bases, a 2 and an x, and it's being squared. So I need to square both of these terms. 2 squared is 4, x squared is x squared. By raising it to the reciprocal power, I got rid of the 1/2 power, and I have 4x plus 8. Now, this is a quadratic. Whenever you have a quadratic function, I want you to think to set it equal to 0, because we're going to try and factor. So I'm going to have to subtract the 4x and the 8 from each side, leaving me with 4x squared minus 4x minus 8. When you factor, the first thing you should do is check for a GCF, which this does have. That leaves me with 4 being the GCF, x squared minus x minus 2. This is a case 1 trinomial, so the factors of 2 are 1 and 2. Using different signs to get to a -1, it would look like this. So x plus 1, x minus 2. Make sure you bring that GCF down with you. And then you just you set each equal to 0. So 4 equals 0. 4 equals 0, that won't give us a solution. X plus 1 equals 0, gives me -1. X minus 2 equals 0, gives me a +2. So now you're just going to check your solutions by plugging them in. I'm going to pause the video and do that real quick. So I wanted to take the time to talk about when it's extraneous. You can see when I plugged in a -1, that gave me a -2 on the left-hand side, but I ended up with a 4 to the 1/2, or the square root of 4, or a +2 on the other side. Even though the numbers are the same, the values are not because there's a sign difference. So -1 doesn't work. It's extraneous. When I plugged in a 2, I got 4 equals the square root of 16, so 4, that did end up working. The last case is when we have two radicals inside of one equation. What you need to do first is isolate the radicals just by moving them on opposite sides of the equation. So I have the square root of x minus 6 equals the square root of 1/3 x. And then we undo by squaring each side. X minus 6 equals 1/3 x. And then we're going to solve. So we combine like terms. I'm just going to subtract the 1/3 x and add the 6. Because 1 minus 1/3 is 2/3. And then I have 6 on this side. I'm going to multiply by the reciprocal. This is all just basic algebra that I'm doing. And then that gives me 18 over 2, or that's... Part B, the radicals were already isolated, so I would just square each side, set them equal to one another, solve for x. I get -28 over 3. the check for part A, it did end up working out, but if you take a look at part B, I'd have a negative root, which cannot happen, so no